Welcome back to Offworld, the show where we talk about all things space exploration and pop culture. I'm Ariel Waldman.
And I'm Norm Chan. Now, Ariel, your conversation today is going to be about a film that's a quite classic film from 1950s, Forbidden Planet.
Yeah, and it's perhaps the first known depiction of an exoplanet in a movie, at least the first known depiction that I know of.
Which is kind of awesome because it is a concept that we as science fiction fans kind of take for granted today. We see films about visiting other planets all the time. And so it's quite novel for this one to be the first.
Yeah, absolutely. So we have two awesome scientists joining us who specialize in exoplanets. And we have a really geeky, fun conversation about exoplanets and how they show up in movies and just kind of everything in between. So let's take a listen. Okay, so we are talking about the movie Forbidden Planet, 1956 film, classic film, and I am joined by two really awesome scientists today. Megan, can you go ahead and introduce yourself and say a little bit about what it is that you do?
Sure. So I'm Megan Ansdell. I'm a postdoc at UC Berkeley right now in the astronomy department, and I study basically how planets form and evolve with time.
Yeah, and Frank, can you introduce yourself and say a bit about what it is you do?
Yeah, my name is Frank Marchis. I'm a senior researcher at the SETI Institute. I design instruments to search for exoplanets, to characterize exoplanets by directly imaging them.
Awesome. So we all watched Forbidden Planet last night. It was interesting. We're watching this movie 50 plus years after the fact. And generally, just what did you think of the movie?
You want to go first?
You go first.
Okay. What I thought about the movie? Well, it's from the 50s. Obviously.
Yes, very much so.
It's my kids watch it with me, and one of my kids told me, that's weird, there is a lot of men in this movie.
Yeah.
Which is kind of true. There is a lot of men in the movie. The special effects make them laugh too. But the story has its charm. I personally like the fact that it's a movie for which the human have mastered the technology of traveling faster than the speed of light, apparently, stealing from some flying saucers from some alien civilization who visiting us, probably. And they start exploring the galaxy and discover and see some exoplanets. I mean, that's in the 50s. That's kind of very advanced.
Yeah, and for people who aren't familiar, exoplanets just means planets around other stars. But yeah, they've developed faster than light technology. They said sometime after the year 2200. Megan, what did you think of the movie?
I tried to, so I agree. It was a bit dated, and you can definitely see that when you're watching it. But I tried my best to sort of remove that thought and see it as somebody who was sitting there in the 50s. And it's really interesting. It was very innovative, and you still see a lot of those features of sci-fi space movies in the ones today. So things really stuck, which was really interesting to see where it sort of originated from.
Yeah, so one of the reasons why I chose this movie for all of us to review was because it may be the very first movie depiction of an exoplanet. And it's in the 50s. Like, what did you think was like sort of interesting about the depiction or the imagination of this exoplanet, given that it's from 1956?
So it's always very interesting to see exoplanets in movies in general because they have to film it on Earth, right? So a lot of it looks like Earth. But in this case, maybe because it was the 50s, they weren't filming outside somewhere in Earth, on Earth. They had backdrops and things like that, so they could really just put whatever they wanted there. And it was interesting that it was sort of this like mysterious place. You couldn't really see big features. And then when they would go into like the garden of the people that were living there, it looked a lot like Earth. So I think it's really hard to sort of create something completely new when you're sort of building it from scratch. But I really liked the vibe we got from the planet. It was very mysterious.
Yeah,
I liked the color of the sky, the color of the vegetation. Mm-hmm. There was 2 moons. That's really caught my attention. The phase of the moon was wrong in the movie. I don't know if you noticed that.
No, I didn't
have the same phase, so it was not it's physically impossible. But it was interesting that they even mentioned it in the movie. Oh, look, it's weird to see the sky with 2 moons. And it's true. It would be weird when we'll be on an exoplanet to see the sky with 2 moons. It was kind of an interesting planet because it's not truly, it's not temperate climate. It's desertic, but there is still some plants. The plants are, and there is water. I mean, I could not
It's
make
very
a
California,
sense.
succulents.
It was full of succulents. That's probably what it is. Yeah. We didn't mention the robot, which.
Oh right.
Yeah. Well, the robot obviously makes a huge impact in the movie, and I don't know. I thought it was interesting actually finally getting to see this robot that has so many references in modern pop culture and everything. What did you think about the robot generally?
The robot seemed very forward thinking. It was an AI basically, right? You could give it some examples of something and then it would just reproduce it immediately. So I thought that was pretty forward thinking, that robot.
Yeah.
And he was already following the law of robotics as well.
Yes, to not harm humans.
To not harm humans.
Yes.
That was part of
that was really interesting to see.
There's this moment where he was stuck into this loop when some human was asking him an order to shoot another human. I kind of like that. In 1956, they already have this ingrained.
Yeah, I mean, I also enjoyed like the little points they made sort of at the beginning about how what the atmosphere was made up of and the gravity levels and, things, it's like in the 1950s, there was all this imagination, but it was nice to see that, those little details of just not just pretending like every single planet is going to be exactly like Earth, that maybe this planet had a bit more oxygen than Earth, so maybe everyone's a little bit high on oxygen during all of this. Was just really fascinating. I kind of wanted to know what the history of our exoplanet knowledge is and where this movie sort of sits within that. So it's in 1956, but I believe the first scientifically discovered exoplanets wasn't until like the late 80s, early 90s. Could either of you like weigh in on like where our history of exoplanets is?
So the first exoplanet was detected in 1995. And that was not an exoplanet like Earth. That was a hot Jupiter, and a planet orbiting around the stars in 3 days. And the discovery was made by what we call radial velocity. So it's by indirect detection, by looking at the motion of the star due to the presence of the planet. So in the 50s, I think the only really assumption they have, there's some books written by people. One of the first writers who mentioned the existence of exoplanets was Giordano Bruno, who is from I don't know which year, but from 1700 or something like this, or 1500. And so that was purely speculative at the time. Maybe tell us a little bit more about the evolution, what we know now about the exoplanets.
So now, that was the first exoplanet, and now we know of thousands of exoplanets, and that's in large part thanks to a mission called the Kepler mission, which was launched by NASA. And Kepler used a different method. They used the transit method to detect exoplanets. But because of that, and combined with radial velocity, because from transit we get a radius of the planet, from radial velocity we get the mass of the planet. And when we can combine that, we can get a density, and then you can start talking about composition. So we have, I think, maybe a few dozen to a few hundred exoplanets where we have mass and radius measurements. So we've gotten to the point of just, starting to characterize the exoplanets and doing that for hundreds to thousands of them. So it's a really interesting time. And what I've always found interesting about exoplanets in movies is that they tend to be characterized by one thing. So it's a water world, or this is the desert world, or this is the ice world. You see it in Interstellar and things like that.
Right. There are all of these planets that are just entirely one thing.
Yeah. And you look at the Earth and that's not the case. But at the same time, I get that it's also a movie, it's a story. You need to draw an audience, the audience needs to remember this is the ice world or something like that. But we do the same thing in exoplanet science. So we take this mass and radius measurement and we get a density and we say it's similar to water. It's a water world. So we actually do the same thing in exoplanet science right now.
The reality must be way more
way different.
And does evaluating tidally locked planets come into play at all, or is that just kind of down the road and our instruments aren't sensitive enough to like figure out it's desert on one side and water on the other, or?
Yeah, we can't characterize it in any detail like that, but you can make models and hypothesize what could be there.
Yeah. So I feel like, exoplanets is an interesting thing because it wasn't until the 90s that we really got started with a lot of like confirmed scientific discoveries of exoplanets. And yet, in Forbidden Planet and in many books and everything, people have imagined planets outside of our solar system. So it's really interesting to see sort of probably centuries long of like fiction and imagination like wait to that moment in the 90s really for it to actually be scientifically confirmed. Is it really an exciting thing for both of you to be working in exoplanet science, to sort of be alive in this moment where you're actually able to confirm things that humans probably just dreamt about for so many years?
In my case, what we are trying to do is to see an exoplanet, not to detect it only, but to see the planet. There is something very special in seeing an object. The first time I've seen an exoplanet that we discovered, that was 51 Eridani, that was discovered with the instrument called GPI. In 2015, we published this. I mean, when we saw this tiny speck of dust orbiting, moving slightly nearby the star, that was something. I know it's just a tiny dot around a brighter one, but we saw the composition as well. We collected photons coming from this body itself. So there is something magical to think that, and I often say that in 1995, when I started working in the field of astronomy, we knew one exoplanet, and in 2015, I was part of a large group of people that took an image of an exoplanet. It's amazing. It's a revolution. Now I show movies in my talks where we see the planets in orbit around the star.
Yeah, one of my favorite movies of exoplanets, I think, was taken by the Keck telescope, and it's of 4
HR 8799.
Yeah, that one. Yeah, 4 planets sort of dancing around a star, taken over 7 years in, I forgot, Pegasus constellation or something. Maybe. So it's just beautiful. But there's only like a dozen or so images and videos of exoplanets today. Like what's sort of the current state of getting images of exoplanets, and where is it going? Are we going to get better images in our lifetime, or are we going to sort of be stuck with pixels? Not that I'm disappointed by the pixels. They are incredibly exciting pixels, but like where are we now, and where is it going in terms of actually getting images of what exoplanets look like?
So when you say images, is to be able to see the planet and the continents on the planet. That's what you want.
Well,
this is going to take a while.
To see more than, to have an exoplanet take up more than just a few pixels, to have it take up, 100 pixels or something. I don't know, 50 pixels, something.
Well, there is various ways to do this. I'm just going to describe. First, it's the crazy way of having a multi-base telescope separated by thousands of kilometers that will observe together the same area of the sky. And by interferometry, we get a resolution like if you had a 1,000 kilometer telescope. And we will get a lot of pixels, like 20, 30 pixels typically. Another way is to look at this tiny speck of light, but by having a very accurate instrument and looking at the variation of this light due to the rotation of the planet at different wavelength, we can build a map of the body as well. We can build a map that will show the presence of water and the continents. This is possible with, I will say, a 20-meter telescope observing Alpha Centauri stars and detecting an Earth-like exoplanet around those. It's possible, it's doable. We just need to build this specific telescope, unfortunately.
What's the exoplanet technology that you're excited about currently, Megan?
So I'm going to play devil's advocate a little bit because Frank is all into taking images, but spectra, I think, are pretty cool as well. They're not nearly as pretty. They could be quite boring just looking at them. But there's a lot of plans for space-based telescopes to take spectra of exoplanets. And that for me is really exciting because you can start getting at the atmosphere, the composition of the atmosphere of the exoplanet, and looking for things like biosignatures to see if it's a habitable world, if there's signs of life. So I'm looking forward to more spectra.
Yeah, so we could actually...
JWST, for instance?
JWST, yeah. Yeah.
So we could actually detect life on an exoplanet before we actually get clear images of it.
Yeah, it's quite complicated. So you can predict what life would create in terms of molecules or groups of molecules in an atmosphere, and then try and go find those signatures in an atmosphere. But people are still working on the details of exactly what is a biosignature, because you can get abiological processes that can also create certain combinations of molecules. So you have to model. The models are incredibly complicated, and I think we're still not exactly sure what we should be looking for, but that's the general idea.
And to go back to this, that's the reason I'm advocating for images. Because if we have an image and combined with a spectrum, by reflective spectrum, then we get way more information. We will be able to separate what's coming from the surface, the atmospheric composition of the atmosphere, the seasonal effects. We will be able to see all of this. So I'm excited by this idea of having multicolor images to get both worlds. A bit of information on the transit of the spectroscopic, and information on the image as well, with the image as well.
Well, so in terms of, in Forbidden Planet, we see this very Earth-like exoplanet. What is, like, if you could pick the weirdest exoplanet that you've learned about in recent years, what are some of the weird exoplanets that exist out there that are weird in terms of, like, nothing like, things that sort of go outside of, like, modern imagination a little bit in either characteristics or whatever we know about it?
I know one, but I don't remember the number. That's the magma world, the Super Io, we call this one. I used to study Io, satellite of Jupiter, known for its extreme volcanic activity because it's close to Jupiter. And we have found an exoplanet, which is very close to its star. And some signatures from the spectroscopic signature imply that this may have a volcanic activity and be basically a magma world, an entire planet with a crust and magma on the surface and volcanoes because of probably some tidal interaction with the star.
So I'll vote for an exoplanet system, which is the Trappist system, which was recently discovered, and it got a lot of press. But the host star is a very late, what we call M-dwarf, so it's much smaller and much cooler than our planet. It emits light at redder wavelengths. And then it's surrounded by 7 planets that are all rocky, around Earth size, and they're very, very close to the star. I think almost all of them are within the orbit of Mercury. So they're very tightly packed. I think 3 of them are in the habitable zone of that star. But what's really cool is that if you were on one of the planets, you could actually see the other planets in the night sky. That's how close they are. So you wouldn't have 2 moons like in Forbidden Planet, but you would have sort of 2 planet yeah, exactly. We don't have a word for it, I guess.
Yeah, no, that'd be awesome. I've read things about exoplanets having like the density of like a marshmallow or something, and things where you're getting into weird sort of physics or physics that certainly makes my brain hurt. With exoplanets, and I think in Forbidden Planet, I think they made some mention of that planet being around for a really long time. Do we have a sense of the ages of any of these exoplanets that we're looking at, and compared to Earth, and how young Earth is compared to other planets we've discovered?
So 51 Eridani, the one that we imaged, which is a Jupiter-sized exoplanet, it's a very young star, a very young planet, because the star is very young. And we always measure the age of the star to estimate the age of the planet. So here we're talking about 65 million years. So it's super young. It's a baby. It's basically a baby planet. Planet discovered by Kepler are probably different because they're farther and there is all type of stars in this case.
It's really hard to measure the age of an individual star. So for young stars, we can get an idea of their age because they're usually still in their cluster. So as things age, the cluster expands and you lose track of things. But when things are younger, they're clustered together. And when you have a population of stars like that, you can use our understanding of stellar evolution to get like a mean age for that group. So up until maybe a few 100 million years, which is very young for stars, we can get a rough estimate of the age. But after about 1 billion years, it can be very hard to date a star. But there are exoplanets around things like pulsars, around dead stars. So then you know that it's a pretty old system.
Would those be pretty deadly planets to be around?
Probably
around a
not.
Pulsar?
Probably surviving something like a supernova or something is probably not a great experience.
It's probably a nucleus a large
Debris.
Jupiter or some debris. So
Right, and so that gets into like, how many planets are Earth-like. I know the word Earth-like is charged because that can always mean so many different aspects of Earth, but how much are we discovering, I guess not even Earth-like is my question, but how much are we discovering that exoplanets are similar to the planets that we see in our own solar system?
Well, our solar system turns out to be quite weird. I think we haven't detected anything like it yet. And I think there's a limit, like less than 10% of sun-like stars would have a solar system like ours. We can put a limit sort of on it so far. And yeah, it's hard to answer that question based on what we know now. But I think one exciting thing is what the possibilities are for life that isn't exactly like what we see here. So for example, I mentioned the M dwarfs earlier. So these are, fainter, cooler, smaller stars, but they make up 75% of the stars in our galaxy.
Wow.
And it's much easier to detect Earth-like planets around them, or Earth-sized planets, I guess, around them. But they emit light at a very different wavelength. They're also very active. They emit a lot of ultraviolet radiation, which may sterilize all life on the surface of the habitable zone planets. It might also help for stimulating life. Speeding up mutations, things like that. So for me, that's the most exciting things. Life that would not look like what we have here.
That's pretty awesome.
Yeah, we have a paper that just been published. Which is the final it's almost the final result of the GPI survey. We observe 600 stars, young stars, and the big surprise for us, and it's a disappointment, is that we don't see that many Jupiter exoplanets.
And Jupiter's so awesome.
The problem we have, and that's something I presented this recently to planetary astronomer, it's a problem because having a Jupiter is key, we think, to bring water in the inner part of the solar system or the planetary system. So if you don't have that many Jupiter, because Jupiter planets are rare somehow, meaning as big as Jupiter and far away from the star, then planet like Earth may be also rare. We're still discussing this. It's a very interesting time for us for planetary astronomy because it was a time where we were publishing a paper every time we were seeing a planet. Now we're publishing statistical papers on planet families and populations. And now we're starting making predictions on the type of planets and planetary system there is in our galaxy. So we're learning, and this will have an impact, obviously, on the type of life we will find, we think. As you mentioned, a lot of M-type stars may have small planets like Earth, but life may be very different there, because we are not talking about a sun which emits light invisible, but we're talking about a body which is very small and with light in the red. So the vegetation will be different. So life will be probably different.
Yeah. Well, so have either of you seen any depictions of exoplanets in other movies that you've enjoyed? I know Interstellar showed some, and Star Trek has tons. Star Wars, getting a bit into fantasy. But are there any depictions that you appreciated in other movies?
A movie that I watched a long time ago was Pitch Black.
Okay, I haven't seen it.
That's also kind of a B movie, but
okay.
It was the story in this case is it's a planet in orbit around a multiple star system, and they have this moment where suddenly the planet will not receive any light because of some eclipse effect and so on. And there is an anti-biosphere underneath the surface of the planet that come up at the time because they don't like light. And they kill almost everybody on the surface of the planet.
Of course, yeah.
You have one?
So I don't watch a lot of sci-fi. Don't tell anybody. Don't tell my fellow astronomers.
We won't tell them millions of people.
No, we are
but one of my favorite movies is Guardians of the Galaxy. And they have a great exoplanet there, which is, I think, made from the head of a god or something like that. It's called Nowhere, Know, Nowhere. And they're like mining the head for biomass and things like that. But it's a planet. They've made it into a planet. It's orbiting a star. I think it's orbiting a binary star, which is kind of cool. So I like when people make things like that up. It makes a little different than just the exoplanet that kind of looks like California that you see in a lot of sci-fi movies.
Right, yeah. Well, and certainly I've seen in like Star Trek, like the different colors of vegetation. Like I think like one of the more modern Star Trek movies like has, I think Kirk running through like a planet where it's all like bright red vegetation and everything's just looks like it's been put through like an Instagram filter almost. That's really fascinating. Okay, so I guess my final question for both of you is, what depictions would you like to see that you haven't yet seen of exoplanets? You know, you both study, exoplanets and what's possible and what's out there. You talked a bit about UV light being maybe a stimulant or something. What are some things that you would like to see movies try and take a crack at depicting?
Oh, I was just thinking about that on my way here. I did not anticipate this question, but I was thinking about it. And I remember I read a book in French, a sci-fi book, which was describing an entire civilization, a biosphere, which was basically living by harvesting the thunderstorm in Jupiter-sized exoplanet. The title in French is Les oiseaux de la lumière, which means the birds of light. And they survive. Those birds, so this biosphere, survive by harvesting the energy from the thunderstorm. And there is an entire system and even a civilization living from this.
Wow.
And it's very different because they don't have solid surface. The biosphere is very different. I would love to see a movie depicting this, something completely different, another type of life. Because often people ask me, why are we always looking for life like our life? Well, you just read science fiction book and they have been trying to find life which are very different to us, or describing life different to us.
Yeah, I think along those same lines, it would be really interesting to see someone really give a shot at depicting life around an M dwarf and all of that entails. I mean, it's a completely unconstrained problem, but just to see somebody really go at it would be really interesting to see in a movie.
Awesome.
So if you're a movie director, contact us. We have ideas.
Yeah, exactly. Well, there's the Science and Entertainment Exchange, which does like really awesome work and getting scientists like you advising movies and trying to get things to be accurate or imagine even more awesome things. So that's always a possibility. Well, thank you both so much for being on the show today.
Thank you,
Thanks
Aya,
for
having
having
us.
So the thing that I thought was really interesting about the conversation that I brought up a couple of times was about looking at exoplanets in terms of sort of their weird factor, looking at them in terms of depicting things that are hard for us to imagine. I know Megan mentioned UV radiation as maybe being a thing that actually affects growth or affects plants and animals in a way that we don't quite yet understand. There's many other areas that we just don't know about exoplanets. And I think that's what's so exciting about studying them today.
And in retrospect, it kind of makes a lot of sense that these two scientists who work in search of exoplanets have to think unconventionally about what a planet looks like, what a planet is like, just all the aspects of a planet, because those are the only ways in which we can infer that those planets are out there. We can't have more traditional ways of just looking out at the sky and seeing a planet.
Yeah, it's an exciting time in science really to both be imaginative, but also to be searching for what's possible and what's out there and not always have sort of these default assumptions that everything is going to be Earth-like. In fact, most of what we've discovered so far is very far from Earth-like.
Right, and I like both their kind of favorite depictions of exoplanets, especially for Megan. She just picked something that technically, I guess, would be defined as a planet, but a giant head from a science fiction fantasy film. And I don't think we'll be finding that one in our galaxy anytime soon, but it's again fun to hear them think outside the box.
Yeah, I mean, it reminded me actually of Stargate Universe, which also depicted planets that were made by aliens. So the idea that planets might not only be naturally occurring things, but they might actually be things that perhaps some other species could actually form itself. I don't know. It was a fun conversation, and I feel like there's just so much more to imagine. And I think that's what I love so much about Forbidden Planet is that it was so imaginative for its time. And even today, I think it still holds up pretty well in terms of imagining what another planet could be like and at least sort of sprinkling some science in there in terms of atmosphere and other things.
Well, certainly better than some of its other attributes.
Yes.
Have held up not as well.
For sure.
Yeah. So we'll be back next time with another topic or or film that you're going to talk about. Offworld, if you enjoy the show, is also available as a podcast. You can go to tested.com/offworld and subscribe there or wherever you download your podcasts. But if you like the video, please subscribe to our channel, like this video, leave a comment below about your favorite depiction of exoplanets in film, and we'll see you next time.